My name is Kurt Wise. I'm a professor at 𝘎𝘕𝘃 University in Cleveland, Georgia. I want to talk about the erosion of the Niagara Falls at the border between the U.S. and Canada. Beginning in about 1830, arguments were made that the erosion of the Niagara River, the gorge downstream of the falls, would take longer than the biblical account says the age of the universe is. That it would take longer than 6,000 years to cut the gorge. So I want to examine that particular issue. If we go back to 1697, we have the first image, if you wish, drawing that we know of the falls. And thus it would be a picture of what the falls looked like in 1697. It's probably a bit fanciful. You're not entirely sure the accuracy of it, but there are features we can identify on here which tell us the position of the falls, roughly the position of the falls in 1697. We can move forward to 1796. We have the first reasonably accurate drawing of the falls, both the U.S. side of the American falls and the Canadian falls. About 90% of the water falls over the Canadian falls, and so we're going to focus here on that. Most of the measurements estimates made on how long it would take to cut the canyon, have been based on erosion rates of the Canadian falls. We move forward to 1818. This is actually a map developed following the War of 1812, and we're settling the dispute on the border between the U.S. and Canada. There was a careful survey of the falls that was made. So this is actually the first very accurate indication of where the falls was in, again, about 1818. We also have another accurate drawing from 1827 from the falls, and another engraving from 1830 that was used by both Robert Bakewell and Charles Lyell to make estimates for the time it took to erode the canyon that have led to the conclusions that we very commonly hear today, that the canyon must have eroded in a much longer period of time than the Bible allows. So looking at a timeline, we have estimates of the position of the falls at various times up to 1900. The reason I stop at 1900 is because at about that time, soon thereafter, about 50% of the volume of water that falls over the falls had been diverted by then into hydroelectric plants. So if you go there today and look at the falls, as impressive as they are, only about half the water of the river flows over the falls. The rest goes into underground tunnels and that sort of thing into various hydroelectric plants. And so measurements of erosion rates after 1900 are basically useless in trying to understand the erosion rate before that time. So we're restricted to this period of time in making estimates of the erosion rate. Now here is what we have then of the drawings of as best we can reconstruct them, beginning in 1795, the position of the falls, the Canadian falls now, water is flowing from the bottom to the top of the diagram. The falls eroded back by 1818 to this red line, by 1842 to this green line, to 1875 to the blue line, and then 1883 to the whatever color that is, purple line there. And so from these we can estimate the amount of time it took to erode between each of these. if we put proper error bars on them, estimates based upon the 18th century measurement is that erosion rate since that time has been about 3 feet per year. Now there's fair bit of error in this because, again, that was a fanciful drawing. We're not entirely sure about the exact position of the falls. So taking all that into consideration, the erosion rate is somewhere between 2 and 4 feet per year since 1795. The later, more accurate drawings of the position of the falls means that we're going to pull in our error bars up and down. Subsequent estimates really decrease to below 2, between 1 and 2, and settle out most recently at about 1.7. If you try to, and by the way, these purple lines are eyewitness accounts that were used by Bakewell and by Charles Lyell to determine the actual erosion rates of the falls. By this I mean that these people talked with folks that lived at the falls, and especially the old people would say, yeah, back when I was a kid, 15 years old, the falls was about right here. And taking these eyewitness accounts, which span the years from the almost towards the middle of the 19th century, actually 18th century, all the way up to about 1840, those measurements very consistently run at about 1.4 feet per year as the erosion rate during these people's lifetime. Those would not be considered, of course, as accurate as estimates from the drawings, because we're taking an erosion rate from those drawings all the way to 1900 to determine, or all the way from that to the most recent survey. So it's taken over a longer period of time, and presumably it's more accurate in the position of the falls. All being told, when you consider everything, it's most likely, and considering where most of the error bars cross each other, that the erosion rate is somewhere a little bit less than 2 feet per year in the Canadian Falls in the late 19th century. Now there's more to see here, because the idea is we have the falls way back down here. Presumably it started at the lake and cut its way back to its present location, where it's still continuing to make its way along here. A few things to keep in mind. Again, the Canadian Falls is not the only falls that are cutting. We also have the American Falls. It's not cutting as much, about 1/9 as much as the Canadian Falls currently is. But we also have, in addition to the canyon itself, we have evidence that at various times the river was actually sitting above the canyon and left river gravels above. This would be evidence of time when, let's say, the falls was here and water was pooling above the falls before it cascaded down the falls and on on from there. Actually, it's going this way. So the falls would have been here. Water is pooling up here, creating sandbars and so on. So there's evidence of the position of the falls all the way along. In other words, that the falls really has moved down in its course to the towards Lake Erie. Another consideration, though, is there's an interesting kink in the canyon, where the canyon actually turns 90 degrees. There's a whirlpool here and this sort of thing. Turns out that there is a buried canyon that continues all the way to the lake. And it's buried with sediments that were brought in by the glaciers. And so the real history of the canyon is more than just this canyon that we can see, and that was the basis of Bakewell and Charles Lyell's arguments. There must have been the erosion of a canyon up to this point before the glaciers, and then the glaciers came along and filled that canyon, and for whatever reason the water began cutting another canyon and continued on to the present. So in order to determine the actual erosion time for the canyon, you've got to consider both the erosion of the canyon we can see and add to it the erosion of the canyon that's buried in glacial sediments. So what do we get? Estimates of erosion times of the Canadian Falls began with Bakewell in 1830, based upon, again, those eyewitnesses. He deduced that it would take 11,000 years to erode the canyon we can currently see, which again is greater than the 6, 7, 8,000 years that the Bible indicates the age of the earth is. So it came as a challenge to the idea that in fact the earth is as young as the Bible claims. Now, being fair, you need to add the buried gorge, and so actually Bakewell's estimate would be about 15,000 years if you considered the buried gorge, which makes it, of course, even worse of a problem for the biblical account. Following Bakewell, Charles Lyell made another estimate of 35,000 years for the erosion of the canyon we can see, and again extending that for the canyon he didn't know about, the buried canyon, would say that it would take 50,000 years to erode the canyons below the Niagara Falls. However, rather than Bakewell, in contrast to Bakewell's estimate and Lyell's estimate, if we used not the eyewitness accounts that Bakewell used, but used the more accurate survey estimates, we get a value of 5,800 to 8,500 years for the erosion of the canyon, and if you consider the buried gorge, somewhere between 85,000 and 13,000 years. You say, well, that's still greater than the age of the earth according to Scripture, and I agree with that, but it's an interesting note here. There's a significant difference here between the estimate, especially by Charles Lyell, and our best estimate here. Now, Bakewell, he does have a larger time of erosion, but it's not nearly as far off as Charles Lyell. If you look at where Lyell's estimate is, Bakewell used the eyewitness accounts here, thus he gets a slightly older age of the canyon than we do with our best estimates from surveys. But Lyell rejected the eyewitness accounts that he had available. He had the same eyewitness accounts available that Bakewell had. He talked to the same people. He visited the United States and was and actually put the erosion of the Niagara Falls into his 1830 textbook, and actually a later edition of it, 1842. But he used we don't have any idea where in the world he got this erosion estimate. It's a very, very low erosion rate, much lower than the eyewitnesses. So he rejected the eyewitnesses. He gives no justification for this. But it's Lyell's argument, it's Lyell's conclusion about the erosion rate of the Niagara Falls that is used to argue against a biblical time scale. So first observation is most of the arguments are based on a completely unjustifiable erosion rate. But let's go back to our consideration of the erosion rate using the best estimates. There are some other things that are going to affect the rate of erosion of the canyon as we look back through time. First of all, the American Falls doesn't contribute a lot, but another 10% is going to be added by the American Falls. So that's going to reduce the amount of time it takes to cut the canyon by perhaps 10%. A second issue that's interesting here, the shape of the Canadian Falls in that bowed-in shape makes the falls about 60% wider than the average width of the canyon. So that's going to work against us because it would seem that the current erosion of the Canadian Falls is faster than probably the average erosion rate that it had while it cut the canyon itself. Another consideration here, this one is a huge one, the rock that is being cut through here at the present falls is 4 times thicker than the same rock unit down here at the lake. So the current erosion rate would be considered, probably it's reasonable to assume it's 1/4 the erosion rate it was at the beginning, and it's probably a regularly decreasing erosion rate as we go along. So the current erosion rate has to be, the thickness of the limestone has to be taken into consideration, which is going to shorten the amount of time it takes to cut the canyon. Another consideration is approximately 16% of the length of the gorge is not through rock itself, but through sediments that are much softer, basically gravel, and would have been eroded in virtually 0 time. So that's going to decrease the erosion rate as well. When you take these things into consideration as best we can estimate it, the erosion time for the visible canyon drops to 2,200 to 3,300 years. And if you consider the buried gorge, it's 3,300 to 4,800 years. Given that the flood, we believe, was only about 4,500 years ago, that means that our best estimate of the erosion of the Niagara Falls Canyon can be accommodated in the period since the flood. So it fits into the biblical timescale. But there's more to be considered. There are further effects on the erosion time, such as the fact that soon after the flood, it's very likely that the rocks were not as well lithified as the rocks are today. And so erosion rates are probably much more rapid soon after the flood than they are in the present. That would make the erosion of the canyon even shorter. Also, glaciers, as I've already indicated, one of the oldest canyon is covered is filled with glacial debris. Glaciers moved across this area and then melted away. They in fact carved out the lakes and would have dumped an enormous amount of water as they were melting into the lakes. That higher rate of water flow from the melting glaciers would cause the erosion of the falls to be much, much more rapid than it is today. So that would further increase the erosion rate. Number 3, we've got in our best estimates of the model of the flood, we have a very warm ocean at the end of the flood, which creates an enormous amount of precipitation, which then moves over the continents and over the cooler continents and precipitates on those continents. We think that the rainfall rates soon after the flood were probably something in the order of 100 times, at least 2 orders of magnitude greater than they are today. That would mean that erosion rates would be much higher, perhaps 100 times higher, immediately after the flood than the present. They would have dropped down to modern rates probably within 300-400 years of the flood, but for quite a while we're going to have a very much greater erosion rate, further shortening the amount of time to erode the canyon. There's also the effect that the glaciers were thick enough, deep enough, extensive enough that they actually bowed down the land in the period right after the flood. As the glaciers were formed, they would bow it down, and it's after the melting of the glaciers that the land has rebounded to its present position. The greater tilt of these sediments with glacial depression would have accelerated their erosion. Also, we have we are not accounting for possibly all of the routes that water could escape from the lake. It might have gone elsewhere. This would increase the erosion rate. Increase the amount of time it would take to erode if, in fact, some of the water is creating canyons elsewhere. It's hard to quantify these things, but collectively, it suggests that they overall are going to increase the erosion rate and further conclude that the Niagara Gorge is very easily cut in biblical time frame. There is no challenge whatsoever on the age of the earth due to the erosion of the Niagara Gorge.